Hello guys, this is Ved Prakash Singh from IITC. Welcome to IITC as usual. Guys, today we are going to see a very important topic regarding the risk assessment, and the topic is quantitative risk assessment, which is normally known as QRA. Probably or possibly you might have heard this terminology, and I'm very sure you might be working for this kind of studies in your day-to-day jobs. So before we start, just I want to give a brief description. In fact, as you know that DNV is the pioneer for few softwares related to QRA. I have taken the support from the DNV leaflets only to give you the accurate, true and consolidated information. So this will be around 10 minutes presentation. Let us see how we can learn very quickly regarding quantitative risk assessment. This is an introductory session. In detailed session, I have different modules, different videos. Those guys who are interested to learn quantitative risk assessment from scratch, and that will be the long classroom training, and that is little difficult, complex initially. If you are not familiar with the quantitative risk assessment techniques, probably you may feel that this is hard and difficult. But guys, this is not difficult. This is a matter of practice and how you are getting trained, which modules you are going through. So I can assure you the technical quantitative risk assessment is not so technical. People have made it technical. Guys, as I have mentioned you that we are going to take the support from the DNV. So yes, we have taken the abstract from the DNV, study material. We will see what is QRA, means quantitative risk assessment. We will see drivers for quantitative risk assessment and why QRA, why we need to do QRA. Next, we are going to see number 3 is challenges that QRA can help address, applications of QRA. That means we will see that what are the applications of QRA. And definitely we will see that what are pros and cons of QRA, because nothing is so perfect. So there are weaknesses and there are strengths. So we are going to see separate what are the pros and what are the cons. Doing a QRA, practical considerations, best practices and pitfalls. I tell you, this is where we need to have a very good knowledge, because here you are going to put the data and your output depends on your input. Garbage in, garbage out. This is where we need to have the very good technical knowledge, and we could have very solid QRA assumptions which will help you to give the right output, and which will also help the reader of the reports, the analyzers of the reports, those guys who are going to use the report, and definitely we will see the conclusion. Guys, now let us understand very quickly what is a quantitative risk assessment. If in this quantitative risk assessment you remove the quantitative, then the remaining thing is risk assessment. So what is a risk assessment? That means we need to understand risk. So what is risk? Risk is basically, it is a two-dimensional point, and you can say that it is the multiplication of likelihood and consequence. So when you have multiplication of likelihood and consequence, this will give you a result which is called as a risk. And then there are two kinds of risk assessment. One is a qualitative risk assessment and one is quantitative risk assessment. Qualitative risk assessment, I have made a pure, very good, crystal clear video for quantitative risk assessment. And I would encourage you, please search in the YouTube IITC space risk assessment. You will find the risk assessment, that is qualitative risk assessment, in our channel, and you can feel free to go for that. Now we are going to stick this session only for quantitative risk assessment. Yes guys, this is a very important slide to understand quantitative risk assessment. Let us give 2 to 3 minutes to understand this slide. If you see here, we are starting here from what can go wrong. This point is also known as hazard identification. Normally, possibly, or most of the time, you know the hazard. If you are in the field of loss prevention, damage control, or you are technical safety guy. But just for academic point of view, I can tell you this point, what can go wrong, can be identified from hazard report, hazard identification report. Correct? So this point is clear with you. Guys, if you have any question, if you have got any query, I would encourage you, request you to please put into comment section so that I can come back to you. After identifying the hazard, then first thing is we need to know that what is the frequency of that event. I would like to give you a very short, simple, ways how to identify the frequency. Normally, I will not take much time. Normally, we need to identify from where the leak can happen and what is the frequency. To identify what is the frequency of leakage, we have to segment it, we have to isolate, we need to have isolatable section, and then in that isolatable section, we need to find out the points of leak. Simply the number of flange joints, number of valves, number of sampling point, from where the leak can happen. Normally, welding joint are not considered as a leak point. Normally, leaks are considered only pipe joints, flange joints, thread joints, valves, blowdown valves, emergency shutdown valves, like this. And then after counting the number of these joints, then you have to synchronize with UK HSE failure frequency of estimation, or ORIDA, or OGP guideline. This we will discuss not here. This is the detailed part. I don't want to distract you. So please understand for this point of time what is the frequency and from where we can identify frequency. Okay. So now I hope this is clear to you. Now we are going to see the how big, if the event happens, how big the event would be. That means what is the consequence? To identify the consequence, we need to have a software. As we mentioned that the pioneer in quantitative risk assessment area is DNV. You may be familiar, Safety, you may be familiar, PHAST. Now the latest version is PHAST 6.8. Now DNV keeps updating their software based on industry's feedback, based on their knowledge, based on their inputs. So then they changed the version. Now the latest version is 6.8 version of PHAST. So if you do the quantitative risk assessment in the latest version, probably you will have nice output. After identifying the frequency and after identifying the consequence, means severity, then we need to multiply these two things to get the risk. And this is also the part of software, PHAST or Safety. And when you are familiar with how to use PHAST or Safety, these jobs become very clear. After identifying the risk in terms of quantity, then we need to identify the control measures. How is that risk is in the intolerable band, or risk is in widely acceptable zone, LR zone, or it is in the widely tolerable zone. After that, once we know that what is the risk and where the risk is falling, then we need to say that what do I do? That means what controls as a risk manager, as a safety engineer, as a loss prevention engineer, as a construction engineer, or as an operation manager, need to think what should I do to bring the risk from intolerable band to acceptable zone, and then from acceptable zone to widely tolerable zone. Correct, guys? So for now, you only understand this. Don't crack your head. Don't get confused. If you are a technical safety guy or you are a loss prevention guy, you want to know in detail. So I would encourage you to please see the detailed training program, which is long training program. You have to give more time on that, but you will have good sufficient amount of information. Guys, now let us understand what are the outputs we are going to get. There are few terminology in the QRA, like individual risk, like location specific risk, like FN curve, like PLL. You don't need to bother right now. Probably you will learn something in the following slides, and I will also give some abbreviations and meaning of that technical terms. Now let us see that individual risk. So IR, individual risk, normally it is counted as IRPA, IRPA, individual risk per annum. If you see there is a triangle, this triangle is known as ALARP triangle. ALARP, ALARP, as low as reasonably practicable. Those who are in the industry, they are very familiar. Those who are students, very familiar. If you are not familiar, treat or learn or understand this is a LR triangle. Correct? If you see in LR triangle, there are different bands. This arrow is there, this arrow is there, these dotted lines are there, these dotted lines are there, these dotted lines are there, and all dotted lines are having some numeric value. If you see here, once in a million, once in a million. Yes, guys, this dotted line has got some numbers. This is a once in a 10 million. Once in a 10 million. This says that if you are here in this band, the probability of failure is once in a 10 million. Here, if you see the second dotted line is saying that once in a million, the probability of death is once in a million. If you go a little upper side, you see that there are dotted lines. There is another, numbers are there. Once in a 100,000. The probability of failure is once in a 100,000. Once, tens, 100,000, 10,000, 100,000. And then if you go on the upper, you are able to see some dotted lines. Once in a 10,000. Correct? Now if you go a little upper, it is saying once in a 1,000. That means the upper you go, it is the riskiest area. The lower you go, it is the safest area or safest industry. In the terms of industry, I can say you, it is the, if you go up, it is the riskiest activity or riskiest industry. If you come down, it is the safest industry or safest activity. In nutshell, I can tell you, riskiest area or riskiest industry, if the fatality or IRPA is once in a 1,000. 1,000 demand, once in a 1,000 demand you can say. Driving on the road, traffic accident, driving 10 hours per week, then probability of fatality is once in a 10,000. Correct? Now, if you come, this is residential area, I can see that accommodation area. then the probability of fatality in this area is once in 100,000. And if you come down here, this is the safest industry, or safest industry says that once in a million. And the lightning during the rainy season, once in a 10 million, the probability of failure. This right side says about industries and occupation. Here if you see the IRPA, if you compare with our activity on normal day-to-day jobs, if you see accident at home, it is saying that you are coming somewhere once in a 10,000. The probability of fatality is once in a 10,000 home accident. If you are a smoker, 10 cigarettes per day, your chance of death is once in a 1,000, right? And heart attack is once in a 1,000. And if you are solo rock climber, 5 hours per week, that means your chance of death is here on the top of the triangle. So what we say here, I mean anything more than this, more than once in a 1,000 is unacceptable risk. And beginning from once in a 1,000 till once in a 100,000, once in a 100,000 is ALARP zone. And anything below once in a 100,000 is a widely acceptable zone, or you can say below ALARP. For this, to understand this, for this point of time, this is enough information for you. Other than those guys who are in loss prevention, who are in technical safety, who are dealing with different kind of risk management jobs. But for the beginners, this is enough information. You do not need to worry. Guys, now we are going to see typical QRA output number 2. It is a societal risk, and sometimes it is known as group risk. It is a relationship between frequency and the number of people suffering from a specified level of harm from the realization of the specific hazard. This is also known as sometimes FN, frequency and number of fatalities. We will see in the following slides the different kind of output of the QRA. Now we will see LSIR, which is location specific individual risk. LSIR is defined in bigger terms. If one person is going to stand there on a specific location, then 24 hours into 365 days. So that risk is for location specific risk. We will see in the QRA detailed training program what is the actual meaning of location specific risk. In other terms, we can say that the risk of that location, of that particular location, is known as location specific individual risk. IRPA means individual risk per annum. We saw that one person is going to work at one location for 365 days into 24 hours, but this is not feasible. Any person is not going to stand or work at one location for 24 hours into 365 days. So sometimes he has to come back in the canteen, sometimes he has to go back in the other things. And if you see here, individual risk per annum on the right side of the graph, it has given the individual risk per annum, that is 1 in 10,000 per year, or 10 power minus 4 per year. Second periphery, if you see here, if a person is going to stand here and the event has happened here, so in that case the fatality is 1 in 100,000 per year, that means 10 power minus 5 per year. If a person is going to stand over here, in the periphery of this red contour. In this case, the chance of fatality is once in a million year. That means 10 power minus 6 per year. So like if the person is going to stand whole year, the individual risk per annum is once in a 10 million per year. That means 10 power minus 7 per year. So likewise 10 power minus 8 per year, 10 power minus 9 per year. So in nutshell, the individual risk per annum is a cumulative risk of a person during the working hours. The person is going from one location to another location, then risk varies from one location to another location, but it is cumulative for 8 hours. So that is why the individual risk per annum is not same like LSIR, because LSIR says that the location specific risk 24 hours into 365 days. So guys, now we are going to see individual risk ALARP principle. If you see a triangle, this triangle is known as a ALARP triangle. And if you see on the top side of the triangle, this is a red by legend. It is a maximum tolerable criteria. And then you see the yellow region of the triangle. This is ALARP zone. And then you see the bottommost of the triangle is a green. This is the desired target, you can say. Now if you go in the red or maximum tolerable criteria, it is unacceptable region. In this case, no work should be allowed to carry on, and no person should work in this zone at any point of time. Risk cannot be justified save in extraordinary circumstances. That means in no case the operation is allowed to run in this zone. Now if you come in the yellow zone, it is showing that ALARP or tolerability region, risk is undertaken only if a benefit is desired. So in this region, it is ALARP, but we have to demonstrate the ALARP. That means we have to do the cost benefit analysis, and the risk reduction is only undertaken when the benefit is desired. If the benefit is not desired, then risk reduction measure should not be implemented. Tolerable only if risk reduction is impractical or if the cost is grossly disproportionate to the improvement gained. Now you are coming to the green zone, which is the bottom part of this triangle. Here, so guys, in this region, it is a broadly acceptable region and no need for detailed working to demonstrate ALARP, necessary to maintain assurance that risk remains at this level always. So I hope you understand the principle of ALARP triangle. In this red zone, no work should be there. In yellow zone, work can be allowed, but we need to demonstrate the ALARP. Risk reduction is undertaken only if a benefit is desired. And in green zone, it is widely acceptable and one work can be done. So next output of this QRA study is societal risk. So now we are going to see FN curve. FN curve means frequency of incident with number of fatalities. Here, if you can see, this is a propane. This light green is for day hour risk, and this light yellow is night hours risk. And if you come here, chlorine, this is a night hour risk and this is a day hours. This is a minimum criteria line, this is the maximum criteria line with respect to FN curve. So this is also, here FPLL, potential loss of life. That means in one incident, what is the possibility of maximum number of death? we are going to see over here in terms of societal risk. So this graph, if you see here, this is also representing social or societal risk, and the risk criteria for different countries are given as a upper limit. Here the black is UKHSC, here light yellow is RDJ and RGDS, blue line is a Victoria, then again dark red is for Hong Kong. So different countries acceptable limit or maximum criteria is shown over here, but normally we use UKHSC for oil and gas point of view worldwide. If you see here, this is examples of QRA applications. QRA is done to assess the life cycle asset risk management in terms of design, during construction, during operation, and during decommissioning. QRA is also done as per the safety case requirement for developing the safety case as per UKHSC. If you are going to have land use planning or plant layout review, so in this case QRA is required to understand the risk at different level and what is the safe distance, between one equipment to another equipment. And of course, operational risk management will also need a quantitative risk assessment result to understand the operational risk management. Compliance. We need to comply with the legal requirement. We need to demonstrate the ALARP to the authority. In many cases, in many countries, we need compliance requirement. For compliance point of view, we need to have quantitative risk assessment. And definitely we need to have the cost benefit analysis for implementing any RRM, risk reduction measures. And the risk reduction measures are to be done when the risk reduction is achieved with less investment. Decision support. For many cases, decision to start the construction in the brownfield, decision to install a new equipment in the field, decision to decommission, decision to shut down or shut down, we need a QRA report to support decision. Equipment design, of course, if the equipment has got a high, IRPA or LSIR, so we need to have the QRA report to support design of equipment. Escalation assessment, yes. If you are adding some equipment or if you are adding some chemical or processes, that for escalation of the risk, we need to have quantitative risk assessment to justify any equipment addition or process or system addition. Layout optimization, size and equipment. Definitely to optimize the layout, we must do a QRA to understand the risk in terms of LSIR, in terms of IRPA. Technology option selections. Yes, the quantitative risk assessment will let us know that if the risk is very high with respect to one and technology A, in that case, we need to go for technology B, where the IRPA, LSIR, FN curve are lesser than the option B. To quantify the benefit of mitigation measures. See, RRM, risk reduction measures. So we need to quantify which RRM is giving how much reduction so that we can select the best RRM to implement to reduce the IRPA. And of course, in many countries, for LSIR, for insurance point of view, we need to support with respect to the QRA report. Guys, this is the result of cost benefit analysis. If you see the graph, on the top this is risk, on the bottom this is the cost. And we are considering one example of base risk. This is the base risk, and the base risk has to be reduced. This level, this level, this level, this level. How this will be reduced? With the help of RRM1, RRM2, RRM3, RRM4. So when you implement RRM1, the cost of implementation is from here to here, and whereas we are having the risk gain, risk reduction like this. Now let us go for the second one. Here the cost of implementation of risk reduction measure 2, RRM2, the cost is very less, and at the same time the risk reduction is also very less. You can see here. Now RRM3, risk reduction measure 3, here if you see the cost is up to here, where the risk reduction is also significant, right? Now RRM4, here the cost of implementation is like this. It is definitely bigger than number 2 and less than 1 and 3. But the risk reduction is better than number 1 case, number 2 case, number 3 case. So in this case, I think it is always advisable to implement RRM number 4, because here cost of reduction is less than amount of risk reduction achieved. So that is why we need to do a qualitative and quantitative study to understand the CBA, cost benefit analysis, with respect to all proposed RRM, and the best RRM has to be implemented with respect to cost and risk reduction achieved. Now let us see the pros of the QRA. This is the pros of QRA. Enable risk to be quantified, offer an objective rational approach to risk assessment, understanding an engineered system, of course, yes. Visual depiction, you can see the visual contours, the graphs and the distance, you can see it here. And identify the highest risk contributors, and you can also see that which action are creating how much risk. This will help you. So likewise, other systems, every system has got the cons. Today and now we are going to see the cons of the QRA. Uncertainty in the risk estimates, addresses by adopting a conservative approach. So here, I mean, we know that, see, this is related to data in, data out. Input is equal to output. Garbage in, garbage out. So it depends on how accurate your data is. Cost per time intensive. Here the cost per time is very intensive. Addressed by software tools such as Safety or FAST reduces the analytical burden approach. Susceptible to garbage in, garbage out. If your input is wrong, then output is wrong. Likewise, highly specialized activity, expertise, DNVGL is available for this case for your help. So guys, with this, I believe, this information was useful for you. And I'm going to post a complete detailed program on QRA, which is, bigger than this program. This program was merely an introduction part, but when you go for a bigger program, you will have complete idea. But for those guys who are the beginner, who does not know anything about the QRA, this would have been useful for you. Guys, with this, I would request you to please subscribe the channel. Please send this link to your professional friends who can also be benefited. And we have a lot of training programs in our website. Please feel free to go through that. And I would request you to please put your comment in the comment section so that we can answer you appropriately. With this, thank you very much. Jai Hind, Jai Bharat. Thank you.